The first step is to log in into our platform. On the left-hand side, you see the project management system. You could create folders and projects. Folders are collections of projects. Here we have created a new folder called Demo, and inside that folder we have created a new project called First Project. Let's start building modules inside this newly created project. Module level top-down menu gives you the ability to create modules at different abstraction levels. In our platform, we provide 7 hierarchical abstraction levels. The modules created at each level of abstraction are graphs of module nodes from their previous level of abstraction. For example, systems are graphs of agents and agents are graphs of nodes. The first level of abstraction is the layers level. At the layers level, we support 50 different layer types. These layer types include the regular layer types that you encounter in deep learning frameworks such as TensorFlow and PyTorch. Also, any data processing operation can be represented as a layer type. We support different activation layers, and for each activation layer, we surface the parameters that impacts its operation. Also, different types of aggregated layers are being supported by our platform, including addition, concatenation, and multiplication. The convolutional layer in our platform allows you to create a variety of convolutional layers by setting the values for kernel size, dilation rate, padding mode, and groups. Linear layer is a fully connected neural network layer that you can set its input and output number of neurons by setting the input and output channels respectively. Computing loss values is essential for deep learning and data processing pipelines. Here we support different types of loss layers. Multi-head attention layer is the building block for LLMs and transformer-based neural networks. The multi-head attention layer in our platform comes with a full set of parameters to configure its functionality based on your model requirements. We support different types of normalization layers. Batch norm, group norm, instance norm, layer norm, and RMS norm are being supported as part of our platform. For each normalization layer, we surface all of its relevant parameters. Using model wrapper layer, you can import any PyTorch module or TensorFlow Keras model into the platform, which is useful for fast experimentation. We support padding layer and different pooling layers. Also, different RNN-based layers are being supported by our platform. The other layer types being supported by our platform include on-stack layer, a slice layer, different evaluation layers, as well as embedding layers, dropout layers, and constant layer. Now that we have reviewed different layers being offered at this level of abstraction, we demonstrate the extensibility aspect of our platform. Relying on the extensibility aspect of our platform, you could create and save customized modules at each level of abstraction and use them in the next level of abstraction as the building blocks to create more complex modules. Here we create and save a customized linear layer with the input size of 16 and output size of 32 and add it to our personal library as a customized linear layer, demo linear. The platform is notifying us that the module is successfully being created. We observe that the newly created demo linear module is being added to our personal library under user layers.